Imagine waking up on the final day of existence. The stars still shine. Galaxies still drift through space. The laws of physics appear unchanged. Nothing seems different. Yet hidden beneath the surface of reality, the universe has already reached the edge of its survival. Somewhere beyond observation, a process has begun that will end everything forever. Not simply life, not merely planets or stars. Everything. This is the day the universe stops existing completely. For billions of years, the universe has appeared stable. Since the Big Bang nearly 14 billion years ago, matter has gathered into galaxies. Stars have ignited, planets have formed, and life has emerged. The cosmos seems eternal on human timescales. Civilizations rise and fall, while the stars above appear unchanged. But modern physics tells a very different story. The universe is not permanent. It is evolving every second, moving toward destinations that may eventually erase reality itself. Everything we know depends on a collection of physical laws. Gravity shapes galaxies. Electromagnetism binds atoms. Nuclear forces stabilize matter. Space provides location, and time allows events to occur. Together these systems create the structure we call a reality. Remove any one of them, and existence becomes unstable. Remove them all, and the universe ceases to function entirely. One of the most unsettling discoveries in cosmology is that empty space may not actually be stable. According to quantum field theory, the vacuum of space is not truly empty. It contains fields that determine the behavior of particles and forces. Some calculations suggest that our universe may exist in a temporary state known as a false vacuum. A false vacuum appears stable, but only because it has not yet transitioned into a lower energy state. Imagine a ball resting in a shallow valley. It seems secure, but a deeper valley exists nearby. If the ball falls into that lower valley, everything changes instantly. The same may be true for reality itself. If vacuum decay occurs, a tiny bubble of altered reality could form somewhere in the universe. Inside that bubble, the laws of physics would be different. The strengths of forces could change. Particles might become unstable. Atoms could no longer exist. This bubble would expand outward at the speed of light, consuming everything in its path. The terrifying part is that no one would ever see it coming. No signal can travel faster than light. By the time the expanding boundary reached Earth, its effects would arrive simultaneously. There would be no warning, no final countdown. One moment the universe would exist normally. The next moment reality would be gone. But vacuum decay is only one possibility. Another scenario unfolds over unimaginable stretches of time. The universe continues expanding. Galaxies move farther apart. Stars gradually exhaust their fuel. New stars become increasingly rare. Trillions of years pass. The brilliant era of starlight comes to an end. Darkness spreads across the cosmos. White dwarfs cool into black dwarfs. Neutron stars fade. Galaxies become silent collections of dead stellar remnants. Yet even then, existence continues. Black holes remain. For vast periods of time, black holes become the dominant structures in the universe. Their gravity consumes surrounding matter and energy. Some contain billions of times the mass of the Sun. They appear eternal. However, according to Hawking radiation, black holes slowly evaporate. The process is incredibly slow, requiring timescales beyond ordinary comprehension. Yet eventually, even the largest black holes disappear. The last great structures in the cosmos fade away. Now the universe enters a nearly empty era. No stars, no planets, no galaxies, no black holes. Only isolated particles drifting through an expanding ocean of darkness. Entropy continues increasing. Energy becomes evenly distributed. No useful work can occur. No new structures form. No new events of significance take place. The universe approaches heat death. Some physicists argue that this state represents the practical end of existence. Reality remains, but nothing meaningful can happen. Time continues, yet change disappears. The cosmos becomes an endless frozen landscape of maximum entropy. But there are even darker possibilities. Some theories suggest that dark energy may not remain constant. If its strength increases over time, the expansion of the universe could accelerate dramatically. Galaxies would separate first, then star systems, then planets. Eventually the expansion would become so powerful that atoms themselves could no longer remain intact. This scenario is known as the Big Rip. As the final moments approach, every structure in existence begins to fail. Molecules break apart. atoms are torn into subatomic particles. Even spacetime itself may be ripped apart by the expansion. There is no explosion, no final flash of light. Reality simply loses its ability to remain connected. The universe unravels completely. Today the universe stops existing completely may not be marked by a dramatic cosmic catastrophe. It may arrive silently, hidden within the deepest layers of physics. A final transition where matter disappears, spacetime collapses, and the laws that once governed existence lose their power forever. Beyond that day there may be no stars, no darkness, no emptiness, and no future. The concepts themselves may cease to have meaning. The universe reaches its ultimate limit, crosses its final boundary, and for the first time since the beginning of time, existence itself comes to an end.